Hello again, it's Cliff here from Down Under. I thought I'd do a little video comparing a Haimer with a touch probe. And obviously we're going to use my impact tolerant touch probe because that's what I have on hand. And I thought we could compare the Haimer's ease of use and accuracy with a touch probe's ease of use and accuracy. We'll put them side by side and run them through a couple of little tests and see how they do. Cheers. Okay, so for this comparison test between the Haimer and the Tormach impact tolerant touch probe, I'm going to use my old workshop touch probe. I don't want to use one of the new ones that I'm just assembling up because I don't want to turn it into a second-hand probe, and they're all packed up in their boxes at the moment anyway. It's been used for over a year, and some of the new probes have got slightly better tweaks to them which should make them a little bit more accurate, but this will be good enough to give a general and fair comparison between the Haimer and a touch probe. So first off, I want to check that the instruments are calibrated. So we've got a light finger indicator on the stylus tip here, and we adjust the concentricity with these 4 little grub screws at the top of the Haimer until we've got it concentric, and we then adjust the needle that it's on 0 with these 2 little grub screws here. We want to get it as close as we can, but we need to remember that these machines are not high precision, high-end machines. There's errors in the backlash, errors in the slideways, errors in the spindle and the R8 collet, and other errors that all add up to making it very difficult to work to high tolerances. You can't work to microns within these machines, but with skill you can work to within a thou. And again, checking the calibration of the touch probe in a similar way. So we've got a light finger indicator on the stylus tip, and we're just rotating it around there. Again, we're not worried about microns. We've got it within about 1/4 of a hundredth. The adjustment is made in a very similar way with little grub screws here at the top. So first off, we're going to set the work offset G54 to XY00. We're going to use a precision gauge, a bore gauge. This is a really good way to do this test because you can independently check the accuracy of the position using a dial indicator. And a dial indicator is a very safe mechanical method of checking something, and it shows the error in both directions, so the offset is actually half the dial indicator movement, needle movement. So we just jogged this XY position until the dial indicator remains steady, the needle remains steady. So that means that we've got it. I'm not worried about getting to microns again, but if I can get it within 1/4 of a hundredth or half a hundredth, that's pretty good. So that's within about 1/4 of a hundredth set up there. Just lift off there. So another thing to consider here is that the length of your dial indicator, or whatever setting tool you're using, is close to the length of the tool that you're going to be cutting the job with. If the tool's short and the dial indicator's long, or vice versa, you're going to get quite big errors because heads are very seldom dead square and they very seldom go up and down vertically. So if you've got a different projection length, you're going to get quite bad errors in the X and Y. So this position is about the right projection length, and this type of dial indicator is good because the face doesn't go out of view. As you rotate it, you can see the needle very easily. So for the test, we're going to see how quickly and easily and accurately each of the instruments finds the center of this lapped die test bore gauge and the corner of this ground block. It'll actually be really interesting to test this Haimer. I haven't used it much. You know, most of you will know it operates on the principle of a self-sacrificing stylus, so that if you crash it, it breaks the ceramic stylus rather than damaging the delicate internals of the Haimer. And so when I bought a spare stylus in case that ever happens. But I found that was quite expensive, and I was a bit nervous about breaking it, and it was one of the reasons for me developing the impact tolerant touch probe, was that this was an expensive option unless I went really slowly and carefully. Okay, well, let's measure the die test gauge using the Haimer. Let's measure and let's find the center of the die test gauge using the Haimer. I won't bother using a stopwatch because you can see on the video slide of progress just how long it's taking. I won't rush this because I don't want to break my Haimer, and I'm not very familiar with it. So jog approximately into the middle position, come down in about the middle of the gauge, jog in about the middle that way and that way. Now we're going to jog in one direction. Whoa! It's a bit difficult with the camera in front of me, but it's just a rough idea. So we're coming into 0. Just click in the last little bit. Okay, now we'll 0 our Y coordinate, and now we'll traverse to the back. Better watch you go the right way or you'll break the stem off. And 0 on the back surface. And then just whoop, we'll just come in here. But that's about right there at the back surface. And then we'll use the DRO and put in a slash, divide by 2, enter, and that divides it in half. Now we can jog. Make sure you go the right way or we break it off. Jog back to 0. And we'll click it round until we're within a micron of 0 on the Y. Now let's do the X. Oh, perfect. So we'll 0 the X. Now we'll back off the other way. This is nerve-wracking when you're not used to it. I don't want to break my stylus stem on camera. I've only got a spare one. Okay. A little bit too far, wasn't I? So I've got to take the backlash out and then come the other way. That's about right there. Okay, now I'll slash the DRO, divide by 2, enter, and then come the right way back to 0. So that's how you'd set the center of a hole. I'll park it on 0. Whoops. Okay. Okay, there we are. We're parked on 0. We're in the middle now. So that's how long it takes to set a hole, a bore, in the X and Y. I won't bother with the Z, but that's the X and Y with a Haimer. Okay, so I've jogged the Haimer to XY0. Now let's just go over to the PathPilot screen and see how well positioned it is. So that was on G55, and you can see I've jogged it over to within a micron. That's a thousandth of a millimeter of XY0. Now we'll just enter in G54, the work offset of the dial indicator, and we can see the discrepancy. So it's out by 26 microns, or 0.026 of a millimeter. That's just about a thou, just over a thou in the X direction, and 6 microns in the Y. That's about half a hundredth. That's about quarter of a thou in the Y direction. So that's not too bad. It's a little bit more out in the X than I'd like, but you know, realistically, with all the other errors in these machines, that's within the ballpark of what you would expect. Okay, now let's time the impact tolerant touch probe. I can be a lot more relaxed here because it's impact tolerant, and if I do crash it within quite a big zone, it won't hurt the probe. Just about ready to go. Let's start it off now. So we'll jog over in the X. Jog over in the Y. Come down in the Z. Stop about there. Find the middle. Find the middle. Come down to about the right depth and run it through a probing routine. Find center, set work origin. And there we are. How long was that? So we've set that up now on G5.6, and let's compare it with G5.4 that we set up with the dial indicator right at the start. Okay, so you can see the discrepancy is 14 microns minus on the X and 6 microns minus on the Y. So that's less than 1.5 hundredths on the X and just over half a hundredth on the Y. So that's pretty good. That's about just over half a thou on the X and quarter of a thou on the Y. So let's just summarize quickly some of the inaccuracy aspects of these low-cost CNCs. And this is a relatively good quality one, the Tormach, better than a lot of the low-cost machines or adapted machines. But it uses a TTS system with an R8 collet, and you've got eccentric errors in the run out of the R8 collet and the spindle. You probably find you won't get that better than half a thou. It may be a thou or more out. You'll have errors in the verticalness of the slideway, the vertical slide, and the squareness of the head. And if the projection length is different, then you'll get errors there. You'll have problems in your X and Y and Z backlash of probably more than half a thou. If you set it very well, you might get it down to half a thou, but typically those errors will be between half a thou and a thou. And you'll have other little errors to do with gib adjustments, slideway errors, twistings in the castings, thermal expansion, and so on. And so if you add all those little errors up, you can't hope to position accurately better than about half a thou. And it could be quite a lot more than that. It takes a lot of skill to position as close as half a thou. Well, I should say it takes a lot of skill to position accurately every time. You can be lucky and the little errors all cancel each other out. That's the easiest way to be accurate, but to actually do it every time, that does take skill. I was going to do a comparison between the Haimer and a touch probe working on the corner of a block as well, but this video will just drag on for too long, so I'll just quickly touch off using the probe. If you're not familiar with probes and this is new to you, PathPilot, for example, have a page with different easy ways of just probing to different corners and centers and so on. Here you can find the middle of a block or the center of a bore, or it'll go around the outside of a block and find the center of it. This is useful for finding the center of the A-axis or the outside of a square or circle coming down from the top. It's got another page to allow you to set your probe up very quickly and easily in the Z, and you can even set your tip up over here if you don't have a finger indicator using this probe tip adjustment screen. So what we're going to do now is just quickly find the center of the corner and set the work origin. See if I can do this without putting the camera on a tripod. So here we are. Ooh. So now it's found that corner and set the work origin in the X and the Y. Please don't think I'm implying that a good quality passive touch probe is more accurate than a mechanical dial indicator type probe like the Haimer. I'm not saying that at all. Those results could equally have been around the other way, with the Haimer showing to be slightly more accurate than the touch probe. It's just that there's a myriad of little errors within these machines that are masking the results. I could do a much more detailed video, and let me know if you're interested, that takes into account some of these little errors and discrepancies in these machines and attempts to compensate for them. I mean, there's different things you can do. Let me show you something here. For example, you can orientate the spindle with a mark on the pulley and orientate the probe the same way each time when you're first calibrating it. That can greatly reduce the variable inaccuracies from the R8 TTS system, which is not an accurate system, and you're almost certainly going to get small errors introduced at that point. And there's other things that you can do, for example, probing in the same direction with each probing routine, which cancels out some of the backlash issues. But there are always errors that you can't account for. Another one I missed is the visual and parallax error with a thing like a dial indicator that could be set slightly out, very easily set slightly out on calibrating or on the final measuring stage, which gives false readings. So you can easily have half a thou adding up to a thou worth of errors, even if you make a really good effort. So let me know if you'd like to see a video and various ways that you can offset for all of these little inaccuracies in these machines. But I think for most of us, we just want to get on and get the job done, and we don't have time to try and drill down to solve all of those very minor problems. And so in practice, what is often better to do is machine your part with what I call metal on. Let's say you're cutting a slot like this in your part, and you want it to be exactly central, positional accuracy, and you want it to be of an exact size. You can set your block up with your probe or your Haimer, and when you're producing your CAM program, produce that program with a little bit of metal on. I think most of you will know what I mean by that. So for example, when you're entering the tool diameter, instead of a 3/8, for example, a 3/8 cutter 0.375 into 0.376 or 0.377. And that will leave metal on in your CAM program. And then you can run the program, machine the part out, and you've got your slot cut. And this is all pretty obvious to most of us, but it's probably a good idea. There might be one or two that don't know about it. So you've machined your part with your program, and then you measure it. And it's a good way to measure an internal dimension is with an expanding parallel like that, or with a slip gauge. If you're working to fine tolerances, a vernier as a digital caliper is not going to be good enough. So you measure your part with a micrometer, so you know the slot. Measure each side with a micrometer, so you know the positional accuracy. And you can say, okay, I was lucky and I got it right and it's within spec. So you can just go ahead, and that's a big time saving. But more than likely it'll be slightly off one way or the other, or the size slightly out. Now you can tweak your 0, 1 or 2 hundredths of a millimeter, half a thou or a thou, one way or the other. Go back and do your CAM program with a slightly different diameter for your cutter and run it again. Now you can be sure, because NC programs and computers repeat themselves very well, that the same tool path will result in the same errors being produced. And now you have the offsets to correct those errors, and your part will be dialed in spot on. And usually that's a lot quicker than trying to understand the myriad of little errors in your machine and trying to remove them all There'll be one or two that just won't go away and you'll have wasted days on it. Well, thanks for watching, guys. Just an update on the little Hallmark impact tolerant touch probe. They've been going for over a year now. Scores of them have been shipped around the world and there's still no significant issues. I'm sort of reluctant to say that because I don't want to jinx it, but all is well. If you're interested in one of these, you can send me an email, cliffhalldesign@gmail.com, and thanks for watching. Cheers.